Welcome to another episode of Learning Maths with Jet Mathematics. I remain your host, Milton Ibiwari John. We are still on the series of factorization, and today we are learning factorization by grouping. Factorization by grouping. In order to successfully factorize certain algebraic expressions, you must group them so as to be able to factorize. We have examples on the board. We have number 1, factorize cx plus cy plus 2dx plus 2dy, and also factorize 3a minus 6b plus as minus 2b. So let's see how we can do that quickly without stress. So for number 1, we have cx plus cy plus 2dx plus 2dy. So to solve this, we are going to group them in twos. We take this 2 and take this 2. And then we follow normal procedure for factorizing binomial expression for this, and also normal procedures for factorizing binomial expressions for this. You are already familiar with that in our previous videos. One of the videos we did before, we have learned how to factorize binomial expressions. So you can visit that video and learn how to factorize binomial expressions. So we'll go straight and solve this problem. So after grouping twos, you get the HCF of cx and cy. So the highest common factor, what they have in common, the highest common factor of cx plus cy is c. So bring that out. The highest common factor is c. We bring it out. When we divide cs now by c, we are left here with what? X. Cx divided by c gives us x. Cx divided by c, the c cancels out, and then we are left with x. Plus cy divided by c, we are left with y. So we are done with these 2. We proceed to the other 2. We look at these 2 terms. What is the HCF of 2dx plus 2dy? 2dx plus 2dy. Very importantly, the HCF, or what they have in common, the highest common factor, is plus 2d. So obviously you can see 2d here and 2d here. So when we divide this term by 2d, by 2dx divided by 2d, we're left here with x. And then when we divide 2dy by 2d, we left here with plus y. Very interestingly, when factorizing by grouping, you always have this term here, this bracket here, and this bracket here the same. We always have this bracket here and this bracket here the same. Otherwise, your work will be wrong. So ensure while factorizing that the bracket here, the bracket you obtain here, and the bracket you obtain here are the same. Okay? So we proceed. We can go ahead to factorize this. We have x plus y s plus y common to this term and to this term. So that is the HCF of this term and this term. The HCF is s plus y. S plus y. So we bring the s plus y out. And then when you do c into x plus y divided by s plus y, we are left with c. And when you use this term to divide s plus y, we are left with 2d. So this ends the solution to this problem. So we can proceed now to get to solve that of example 2. But remember again, first step, group in 2's. Second step, factorize these as a binomial expression and also factorize these as a binomial expression. And then you are left with these two. You obtain these two terms. You can use the methods we taught in factorizing larger expressions and also break down this to this. I believe that is clear. With the second example, it will become clearer. So let's see that. Example 2, we say 3a minus 6b plus ax minus 2bx. Remember I said group in what? In 2's. Group in 2's. So we are going to factorize this binomial term here, this 2 term, algebraic term. We look at this is 3a and this is 6b minus 6b. What is the highest factor of 3a and minus 6b? 3 can divide 3. 3 can also divide 6. So I think a and b are not common. So the highest common factor of this is 3. So 3a divided by 3, we have a, okay, and then minus 6b divided by 3, we have minus 2b. We are done with this first group. We proceed to the second group. We have plus ax minus 2bx. Obviously, s is the highest common factor between these two terms. There is nothing else can go. We only have x that can go into these two terms. So we factorize it out. That is the HCF. As divided by x, we are left here with a minus 2bs divided by x, we have 2b. If you expand this, we'll get back this. If you expand this, we'll get back this. So we are done with the factorization of this second group. At this point, remember I told you, whenever you get to this point, what you obtain in this first bracket is also what you obtain in the second bracket. If not so, your work won't be correct. Okay? So at this point, we take out what is common here, which is obviously a minus 2b. So we bring that out, a minus 2b. And then we are left here with 3 and here with plus s. So plus s plus 3 is left here, plus s is left here. So this becomes the two factors of this expression. I believe that is clear. So don't forget to comment, to share and like this video.